Alright, we're going to be looking today at setting into a new unit, the Introduction to Polynomials. And so I'm just going to set up my timer here because I'm only able to record a 15-minute video, and we're on our way. Okay, so it says a blank is a product of numbers and or variables. This is known as a monomial. And we'll look at some examples of that briefly. If you have a sum of one or more monomials, this is called a polynomial. Now, more specifically, a binomial is a sum of two monomials, and a trinomial is a sum of three monomials. So this means that a monomial, a binomial, a trinomial, these are all special kinds of polynomials that have one term, two terms, or three terms, respectively. So the first example, which of the following are polynomials? And if they are not polynomials, we need to explain why. This first one here is a polynomial because it is expressible as a product. We can write it as -8 times 1, let's say. Or maybe you could write it as -8 times x to the 0. The point is that you can write it out as a product. So yes, it is a polynomial. However, part B is not a polynomial because it is not expressible as a product, a pure product. I know that some of you might be thinking that you could write it as 3 times 1 over x, let's say. But 1 over x itself is not expressible as a product. Those of you who are thinking that you could write it as 3 times x to the -1, well, keep in mind that x to the -1 means 1 divided by x. And anything with a division in it means that it is not a polynomial. Okay, so we'll just write a little note that says has a division in it. Okay, part C, 5x squared minus 3xy plus 7 over 2. Well, this first term here is definitely a monomial because it's a product of 5 times x times x. The second term is a monomial because it's -3 times x times y. And I know that based on part B, you might be thinking that this third term here is not a monomial because it's 7 divided by 2. But 7 divided by 2 can be written as simply 3.5, can't it? And so a division by a number is not a problem. Where this one has a problem is a division by a variable. So maybe I should say it has a division by a variable in it, because that's the real issue, why part B is not a polynomial, while part C is a polynomial. Part D, we have 4 to the power of x. Now, you'd be correct if you thought, well, you can express this as a product, 4 times 4 times 4 times 4, a total of x times. But because we don't know what x is, then we have to say, no, it is not a polynomial. This is actually known as an exponential function, and we'll study them in the second semester. Okay, so we've got, I'll say we have a variable in the exponent, and that's not allowed to classify it as any kind of polynomial. Part E, again, this is not a polynomial because it has a, maybe I should say it has a radical, a variable in the radical, as my explanation of why. Part F, no, not a polynomial. Again, because we are forced to do a division by something involving a variable. Dividing by a term with a variable. And part G, this one is, let's look. Well, the first one is a monomial, isn't it? Because we've got a number, 2/3, multiplied by x 7 times, x to the power of 7. And the second term is a monomial because we got a coefficient, 0.976, times a bunch of x's. But the third one is not a monomial because it has a negative exponent. And we know that this means that it's -2.81 divided by x cubed. So no, and we'll say that a variable has a negative exponent. So you can't have a variable in the exponent, and we can't have a negative exponent of a variable. However, something like 3 to the -2, that's no problem, because that's simply expressible as the number 1/9. And we're allowed to divide by a number. It's still a polynomial in that situation. Let's move down a little bit, and we get to the part that says the blank, the degree of a polynomial is equal to the highest degree of each of its monomials. And we find a degree of a monomial by adding the variable's exponents. So in this next example, we need to describe each polynomial according to its degree and its number of terms when simplified. Well, 2 to the power of 4, you might think that this has got a degree of 4 because it's got an exponent of 4, but we're only interested in the variable's exponents. This I could rewrite as 16, and 5 times x to the 0, that's just 5, so it simplifies to 21 minus x. Now the x I can write as an x to the power of 1. The degree of 21 is a degree of 0, right? It doesn't have, you can think of it, I suppose, as an x to the power of 0, if you like, if you want to actually see that 0 happening. So it's 21x to the 0, maybe you think of, minus 1x to the 1. So this one's got a degree of 0, this one's got a degree of 1, and therefore the degree of the overall polynomial is 1. We take the highest degree of each of the individual monomials' degrees. We can also see in my simplified expression that it is a binomial with only 2 terms. Alright, part B. I can't simplify any of this, so it's clearly a trinomial because it's got 3 different terms in it. Let's look at the degree. This first expression, my variable's exponents are 7 and 9. That's a total of 16. In the second one, don't forget your hidden 1s by the x and the y. That's actually got a total degree of 17. And this last one at the end, you can think of as a 1x to the 0, a y to the 0. You can add as many variables as you want, but when you add up all of those variables' exponents, their respective degree is 0. You compare your 3 degrees, 16, 17, and 0, clearly this one is the highest, and so therefore the degree of the second polynomial is 17. Always look for the highest of the monomial's degrees. And part C, negative pi, we can express if we wanted as negative pi times x to the 0, y to the 0, z to the 0, and so on. But clearly, it's only the exponents of the variables that we're interested in, and when you sum all of those up, we end up having a degree of 0. And because it's a single term, we call it a monomial. All right, just one thing in there. To add or subtract polynomials, we need to add or subtract their like terms. That is to say, the terms with the same variables and exponents. If we want to write the answer in standard form, well then we want to write the terms with the highest degree first. The ones with multiple variables will use the first alphabetical variable as our guide. So I'll show you what I mean. Let's work on this first example. We're adding together this trinomial with this binomial. So the brackets aren't really doing anything in the first expression, so let's just change it to 5 minus x plus 4x squared. And then I'm adding negative 3x squared, so perhaps I can just think of this as a minus 3x squared. And I've got plus another 4x. Now let's add together all of the x squared terms first. I've got 4 of them here, negative 3 of them here. That's a total of 1x squared. Now let's add together all of the linear terms, the x terms. I've got negative 1 of them here. I've got plus 4 of them here. That's a total of 3. And now let's add together all of the constants. The only constant is a positive 5. And you'll see that I've written it in standard form because my term with the highest degree is at the front, and then they go down in decreasing order until I get to the term with the lowest degree at the end. Part B, I'm now performing a subtraction. The parentheses in the first expression don't do anything. So 5x to the 4y squared plus 2x squared y to the 4 minus 3x cubed y cubed. And I'm subtracting the 2x cubed y cubed. And I'm also, as I distribute the negative to the negative, it becomes a plus 4x squared y to the 4. Now all of these terms have got a degree of 6. So how do I decide what goes first? I've got to put in the 5x to the 4 is going to go first because it's got the highest degree of the 4. So 5x to the 4 y squared. And then x, because it comes first alphabetically, I'm interested in seeing its descending degree, so that's going to be the x cubed, y cubed terms. I've got a total of -5 of them. And lastly, I've got my x squared y to the 4 term, because although all of them have got degree of 6, I'm going to use my first alphabetical variable as the guide. And we've got 6. And I'll continue with this video in part 2.